Hello, Professor Gertner. My name is Adam Ibrahim, and this is a demonstration of my single-cycle CPU Lite, which executes both R and I-type instructions. R-type instructions take two registers, which are a form of memory, perform a binary operation on these two registers, then place their output in another register. I-type instructions take a number that's stored directly in an instruction, which is called an immediate, and perform an operation on registers using that immediate. In order to control my CPU, I use these buttons and these switches. First I'll start with the switches. Switches 0 through 9, these 10 switches here, I use to enter instructions. Instructions are 32 bits wide, but I only have 10 switches, so I had to get a little creative. These first 8 switches allow me to input data 8 bits at a time, and these two switches here allow me to choose which 8-bit region I enter data into. And then finally, see what's going on, see what we're doing. We have our display, and we have these two switches to change what that display shows. So right now, the display is showing the current instruction to be executed. You can see that here because these 4 switches are C. This is the last region. Here you see in the last region. If I put the switch up, I get to see the last thing that came out of the ALU, or Arithmetic and Logic Unit of my processor. And if I put this switch up, then I get to see the program counter of my processor. Real CPUs don't fetch their instructions from switches or from a human operator. They fetch their instructions from a memory. That's what the program counter is for. It keeps track of where to fetch the next memory instruction from. It's an address. Lastly, I use these switches to control some aspects of the CPU. I use this for finalizing which instruction to put in, since I can only do 8 bits at a time. I use this to put one clock cycle of my CPU, so every time I push this button and then let go, one instruction, the instruction that's shown here, will be executed. So what I'm going to do with my CPU is I'm going to put the value 2 in one register and the value 3 in another register, and then I'm going to add them, take that value and put it in a third register, and then we're going to see if we can compare values by putting that sum in another fourth register, comparing those last two, and affecting the program counter based on the result. So first, we're going to set two registers to 0 so that we can freely add to them, make one 2 and make one 3. So to set the register 0 to 0, that's the instruction, which is has already been placed on the board for convenience. And when I execute this instruction, my program counter should display 4, and my ALU should display 0, like it currently is. So I push this button to execute the instruction. The ALU is displaying 0. My program counter is 4. To set the next register, register 1 to 0, we're going to perform this instruction, the AND immediate instruction, and we're going to change the register operands here. Because we're taking an AND, a bitwise AND, with the entire register, and we're putting 0 as that immediate operand, it's always going to come out 0, because one thing and 0 always come out to 0. So the instruction is going to be 0C210000. We're going to put that on the board right now. 0C, 1, 2, push this button to finalize the instruction. 0C21, good. And when I push the rightmost button, start my clock cycle, my ALU should display 0, my program counter should display 8. No changes, still 0. Look at my program counter, most definitely 8. Next, we're going to add 2 to register 0. This is the instruction here. 2 to register 0, store in register 0. And this is what we're going to have to put in. 04000002. There we go. So this is 0 plus 2, so the output of the ALU should be 2, and my program counter should increase to 12, which is going to show up as C here, after I press this button. That's the 2, the expected results. The program counter is C, or 12. Now we're going to add 3 to register 1, so that's add 3 to register 1 and store in register 1, and this is the instruction that we're going to have to put in. That is the instruction. After pushing my clock cycle button, output of the ALU should be 3. My program counter should become 10 or 16, in decimal that is. Push this button. Expected output, that's 3. And 10. Next, we're going to add the contents of register 0 and 1 and store them in register 2. So that would be 2 plus 3 equals 5. And that's the instruction we have to put in to do that. 0, 0, 2, 0, 1, 0, 0, 0. 2, 0. That's the correct instruction. Now the output for my ALU should be 5, and my program counter should turn to 14 or 20 in decimal. After I push this button, it's a 5, and that is 14 in hexadecimal and 20 in decimal. So this is our next instruction. We're going to take the same sum from before, 5, and place it in register 3, so we can use it in the next instruction. And the instruction, the way the instruction looks like is 00201800. This is the encoded form of the instruction, so that the CPU can understand it. We've already placed it in here for convenience. Output of the ALU should stay 5, but the program counter should turn to 18 in hexadecimal, which is 24 in decimal, after I push this button. Program counter changes as expected. My ALU output is still 5, like I expected. So this is the instruction here, already entered for convenience. After I execute it, you should see the program counter decrease by 4 instead, going to 14 in hexadecimal or 20 in decimal after I push this button. And it goes back down to 14. Thank you very much for watching. This has been a demonstration of my single cycle CPU.